Hello everybody, welcome to this quick introduction to this NPTEL course titled Algorithms for Big Data. So you may be wondering, what is big data? Why do we need to care about it? And why should you enroll in a course that deals with algorithms for big data? Well, to set things in context, you have to think about the last 10 to 15 years. There's been a tremendous growth in the amount of data that is generated in this world. A lot of this has to do with the development and popularization of the internet. For example, there's a lot of useful information that is contained within online social networks. So if you are a business that would like to advertise to a targeted audience, it is in your interest to understand online social networks and reach out with your product information to targeted audience within that social network. However, there is a problem. The information is not easy to access, it's not directly available to you. To be a bit proverbial about this situation, it's kind of like drinking from a fire hose just because of the amount of data that is out there. And moreover, the amount of data is so large compared to the useful information that is relevant to you. So, for example, if you are a small business trying to advertise your product to a targeted audience, the problem is you don't have access directly to the targeted audience, but the whole social network in some way, shape, or form. And now you have to search for the proverbial needle within this large haystack. So we really need to build some appropriate tools in order to be able to elicit the useful information that we are seeking. So as an algorithm designer, we ask the natural question, what are some tricks that we might be able to bring to the table? Well, let's break down the tricks. One is a set of mathematical tools that we will need to know, and the other would be a set of algorithmic models, frameworks, questions, if you will. In terms of mathematical tools, some of the key players are probability theory, linear algebra, high dimensional geometry, because a lot of the information out there is very high dimensional, and so on and so forth. And in the context of algorithmic models, there's a variety of models that are designed particularly to address some specific issues that arise in the context of big data. One of the prominent models is the model of streaming, where this captures the notion of data just flowing through a computer at a very high rate, and the computer is just able to look at the data in one pass, and the data is too large to be stored in the computer, so the data has to be processed very quickly. A small amount of information can be maintained as the data passes by, but at the end we need to have some useful information about the data. So this is a very standard, well-studied algorithmic model, and has led to some very interesting and useful insight for the practitioners. Similarly, there's this other alternative model that's useful in particular when the data is available in some cloud or data center, and the only access you have for the data is via well-designed queries into the data. So in this case, you need each query might cost you something, and one could potentially read the entire data, but that would be too much information. And so you want to obtain some useful information about the data without really reading the entire data, but carefully querying different parts of the data. And that's captured in the notion of property testing and the larger aspect of what is called sublinear algorithms. And then, of course, there is a lot of interest today in learning theory, mainly because, again, people want to understand and have some automated ways in which data can be learned and appropriately used. And fourthly, data is not always stored in one single computer, simply because of the massive nature of data. So if you think of data centers owned by big companies like Google and Amazon and so on and so forth, they have large data centers, and the entire data center stores the information that the company holds. And so any processing of the data will require a good understanding of how the data is stored in this distributed setting, and how to process it, and how to access information as needed. And so, as you can imagine, there's a lot of aspects to algorithms for big data. For our purpose, however, we're going to be a little bit more targeted in our approach. Our focus is primarily going to be on probability theory, so that will be the mathematical foundation on which this course is going to be built. And once that basis is built for us, we will be presenting some algorithmic models. In particular, we will be focusing on streaming and property testing. So the course is really divided into 3 modules. In the first module, we will be presenting the basic probability theory that is needed in order to understand and appreciate this area of algorithms for big data. And then in module 2, we will be presenting streaming algorithms and sketching algorithms, a variety of them. And finally, in module 3, we'll be presenting property testing algorithms. So this is the brief overview of what the course on algorithms for big data entails. So I hope to see you in July. Thank you very much.